Hello and welcome. In this video we will learn how to do double integrals again with composite Simpson's rule, but now we will do the double integral within non-rectangular region. This is rectangular region and we have this non-rectangular region. So what is non-rectangular? The non-rectangular region means the lower bound and upper bound on y-axis here is not fixed. It changes as the coordinate of x change. So we have this function cx and dx. So let's do the calculation. So to do the calculation is as we did before, we do the integrals within the square bracket here, and because we have this upper bound and lower bound as a function, not as a fixed value, we will produce this result. It's similar to this part within the square bracket is similar to what we have in the rectangular region, but the difference is the step size on y depends on x, as you can see here. So the hyx is dx minus cx divided by 2 multiplied with ny, and the y as a function of g itself is equal to c at x coordinate plus g multiplied with hy, and in this case the g start from 0 to ny, so I need to change it as well. Okay, so after we have done with this, go to the next, which is the integral of the whole terms here. As you can see, the integrals of the whole parts, and we have a lot of terms actually, and we have the multiplication of the function here. So we introduce a simplification where hy multiplied with fx as equals to gjx, and then the whole integrals here becomes like this. The g to n, this is ny, right? This is ny. Okay, and now how do we integrate every terms here? So again, we introduce simplification. We use integral 1 j is equal to a to b. Remember here, a and b is the fixed value, the lower bound and upper bound of the integrals on x axis. So the gjx dx equals to like this, similar to what we have in Simpson composites rule, but be careful here, we have the step size hx. This is a constant because we have b and a as a constant. Okay, and xi is equal to a plus I multiplied with hx, and I itself is start from 0 to nx, nx is the number of division on x axis. So the final result of the non-rectangular region is basically again we have this nice expression. The double integral is the summation of the integral in one direction, or integral in one variables here. But the difference is we introduce a new function here, j as a function of x, as you can see here. So as an example, we will solve this problem, and we will apply this algorithm into the code in the Fortran. So how do we do that? Let's take a look at the code, and here is the code we introduce. We name it double integral 2. The double integral 1 is the rectangular region. So this is the non-rectangular one. And we have lower bound and upper bound integral on x, lower bound and upper bound integral on y, and also an x and y, the number of division on each axis. And we have a step size here. We define the step size as well. So let's go to the main part here. And as we can see here, what is this? Let's go to the final result here of the integrals. This line is basically calculating this part, integral 1 O, where j equals to O, right? So we have this, and the next line calculates the j equals to 2 multiplied with 2 times ny. So we have this. Remember, this is ny. Okay. So we have similar expression as we did in the text, and in the next is calculating this part, the next term. As you can see, we start from 1, j equals to 1 to 2 times ny minus 1 with the step size of 2, or in a different expression we use 2j minus 1 with j equals to 1 to ny. So it's basically they basically has the same meaning, this one and this expression. And the next is here, this part. It computes the last part of the integrals here. It starts from j equals to 2 to multiply with ny minus 2 with step size of 2. And we can go to the subroutine integral 1. Remember, in this subroutine, it's a bit different to the subroutine we have in rectangular region, because we introduce the y as a function of c. C itself is a function of x. So in this case, we introduce g and y variables here. So the thing is, as you can see here, well, actually the difference between the rectangular and non-rectangular region we can observe as well from this expression. We have this line. It computes gj where x equal to xo here, and the next line here, it computes gj when x equal to x to ny. So this is this part. Oh, it is not m. Okay. And the next is, as usual, we do the loop statement here. We do this calculation, this part, and the last part of the integrals here in the code computes this part of the expression. And if you have a different function, you can modify this function. Also remember to, if you have a different function of lower bound, you can modify this line, and the upper bound you can also modify. Where's the upper bound? C, D, O here. The upper bound, D as a function of x, and the rest is automatically adjusted. So I think that's all for this double integral with rectangular region, and in the next video we will learn how to modify this program to solve our double integral problem with Fortran. So see you in the next video. Bye.